Welcome back, everyone. Here we are with our Patterns in Algebra lesson 5-7. It's our 7th lesson in this unit. And today we're looking at problem solving with t-tables. So in this unit, you will use t-tables to solve problems that involve increasing. Remember, increasing means getting bigger, and decreasing. Decreasing means getting smaller sequences. So we have increasing and decreasing sequences. And we will use multiplication sequences to solve growth pattern problems. So here's our first one. Braden started babysitting in the middle of June and earned $20 in June. He continued throughout the summer and earned $25 every month after that. He saved all the money. How much money did he save through the whole summer? On this side, on the left, we have a column for month. So it tells us how many months there are. He started in June and he went through the summer, which would be July and August. So we have just the 3 months listed there. And over here, note that we have the savings. This isn't the amount that he made each month, but this is how much he saved. So we're assuming he didn't spend any money. He just put it all away in the bank, or possibly in his piggy bank in his room. We don't know. So he started with $20 in June. Now here we want to know in the circle, how much more money did he get in July? And we know he earned $25 for every month after that. So we're going to add 25. Here we have an increasing sequence. So 20 plus 25. And we know that that will give us 45. So now his savings are 45. In August, he also earned 25. So we're going to add 25. And we know that this is dollars. We've got that up here. So we don't really have to say the dollar amount. We can just say the numerical amount. 45 now plus 25 will give us the total savings to the end of August. Well, 5 plus the 5 will be 0. 4 plus 2 is 6. And the 1 from that, or the 10 I should say, from that 5 plus 5 will be 7. So how much money did he save through the whole summer? He saved $70. Here's another question for us. Ray's family is hiking the Trans-Canada Trail. And that's a trail that goes all the way from the east coast to the west coast in Canada. They hiked 11 kilometers on Saturday. Notice I'm underlining the important things that we need to know, but then decided to pick up the pace and travel more quickly. Now they are hiking 14 kilometers each day. First, let's label this A because we've got a 1 up there. So A, the first thing we need to do is make a t-table to record their progress. So I drew this over here already. What are we going to put in the first column? Well, here we want to put the day. So the name of the day, we know that they started on Saturday and they traveled 14 kilometers each day after that. So we're going by days. And what are we going to put here? What do we want to know? We want to record their progress. So we're not going to record how far they went each day. We're going to record their progress along the trail. So make sure that you've got the correct titles on your t-table before you start. Look at what you're trying to find out and then fill it in. Okay, so you can see I've just filled in here the days of the week. Started on Saturday, that's the first day that we have a distance for, and it says they're going each day. Make a t-table to record their progress. How do we know how far to go? Our next question asks us, how far will they have traveled by the next Sunday? So we know they're not talking about this Sunday, the Sunday right after Saturday, but they're talking about the next Sunday, the week after. So that's how we knew that we had to go all the way to the next Sunday. So now let's go back and fill in the progress. They started by hiking 11 kilometers on Saturday. Then they decided to go a little bit more quickly, and they're going 14 kilometers each day. So where do I want to put in that 14 kilometers? That's right, we're going to put it in here because this column records their progress. The first day they went 11 kilometers. But then they picked up the pace, so on Sunday, their progress would be how far they went on Saturday plus how far they went on Sunday. That would be how far down the trail they are. So 11 plus 14, 1 plus 4 is 5, and 1 plus 1 is 2. So 25 kilometers on Sunday. And we should have put up here that it's in kilometers. I forgot that part. So if they traveled 14 kilometers each day, we can fill in all of these with plus 14, right? To the very end, they stayed very consistent, going 14 kilometers each day. So now all we have to do is take the number that we left off with on their progress, add 14 to get their progress for the next day. So 25 plus 14, 5 plus 4 is 9, 2 plus 1 is 3. 39 plus 14, 9 plus 4 will be 13. So we'll carry that 110 over to the next column. Keep that in your head. 3 plus 1 more will be 5, 53. 53 plus 14, 3 plus 4 is 7, 5 plus 1 is 6. 67 plus 14, 7 plus 4 is 11. Carry that 1 up again for the 110. 6 plus 1 more will be 8. 81 plus 14, 1 plus 4 is 5. 8 plus 1 is 9. 95 plus 14, 5 plus 4 is 9. 9 plus 1 is 10. And 109 plus 14, 9 plus 4 will be 13. You can put the 1 there because 0 plus 1 will be 1. And 1 plus nothing is 1. So how far will they have traveled by the next Sunday? Our answer is 113 kilometers. You can see how we can fill out a t-table to show their progress by adding how far they went each day to give us their total progress throughout the week. Here's another t-table that we can create from a pattern rule. And this one we would call a table of values, because here we're not necessarily giving it a real title in terms of a day or anything like that. It's just the term number. And this should look familiar to you from what we did before when we had our sequences that went like this. But now, instead of having our sequences going sideways like this, we've taken these numbers and put them into a table over here. So remember when we said this would be our first term number, second term number, third and fourth? That part is right here. Okay, so we've just taken this format and turned it on its side. So in this, our pattern rule is to start at 3 and add 5 each time. So our first term is 3, that's where we're starting at, and we're adding 5 each time. So we would add the 5 in the circle over here. 3 plus 5 is 8, and that gives us our second term. We know that we're going to add 5 each time because that's what it says in our rule up top. We can fill these in. And we know that our term number is going to go up by 1 each time. So we start with the first term, second term, third term, fourth term, and fifth term. So then we just need to go back and fill in these values for the term value or the number in the sequence. So 3 plus 5 we said was 8. 8 plus 5 will be 13. 13 plus 5 will be 18. And 18 plus 5 will be 23. So we could write that as a sequence, 3, 8, 13, 18, and adding in our fifth term there, 23. And here's the term numbers, 1, 2, 3, 4, 5. So you can see how we can take the sequence and just turn it on its side to make the t-table. Here it asks us to make a table of values for the pattern rule to find the term value or term number asked for. So the first one here says to start at 2. So our term value is 2. So we want to add 6 each time. So here in the little circle that we didn't draw yet, we're going to put plus 6. Now it asks us to find the fifth term. So we know we're going to have to go all the way down to 5. So here we've got 3, 4, 5. This is the term that we're looking for, the fifth term. So the term value, 2 plus 6, will be 8. We're going to add 6 each time, so we can put those in the circles over here. 8 plus 6 will be 14. 14 plus 6 is 20. 20 plus 6 will be 26. So what is our fifth term? Our fifth term value will be 26. Okay, and here's another one. Here it says to start at 18 and subtract 1 each time. So here we have a decreasing sequence. So our term number, 1, 2, which term are we going down to? It asks us which term is equal to 10. So that means we want the 10th term number. Let's fill these in. 10 term numbers. We know we're starting at 18, but what's going to go into our circle over here? That's right, subtract 1, because that's what our rule says, to subtract 1 each time. Start at 18 and subtract 1 each time is our rule. So we could go down, subtract 1 in each of these circles, all the way down to here. And this one is fairly easy because it's pretty easy to subtract by 1. You just have to count backwards. So from 18 minus 1 would be 17, minus 1, 16, minus 1, 15, minus 1, 14, minus 1, 13, minus 1, 12, minus 1, 11, minus 1, 10, and minus 1 would be 9. We're looking for the 10th term, which is right here. So the value for the 10th term is 9. So our answer is 9. This one's a little bit more complicated. Here we have a word problem with a multiplication sequence. So here it tells us a gardener loves dandelions, so he never pulls them out. The number of dandelions in his backyard doubles every year, and you've probably seen this happening. If you don't pull dandelions out, they do multiply, don't they? So let's just assume that the dandelions double mathematically. So if you started with 2 dandelions, how many years would it take to have more than 100 dandelions? Take a guess. Think of how many you think it would be. How many years would it take? Maybe 10 years? Maybe 12? Would it take only 5 years, like they have on the table here? Let's find out. So if the dandelions, the number of dandelions doubles each year, what does it mean if it doubles? What do we need to multiply by? Yep, we know that if it doubles, that means we multiply by 2, right? So that's what's going to go into our little circles over here, times 2 and times 2. Let's stop there for now and see how far we get. 2 times 2 is 4. So in the second year, he'd have 4 dandelions. First year he started with 2. Second year he has 4. How many in the third year? 4 times 2 is 8. So in the third year, he would have 8 dandelions. 8 times 2 is 16. 16 times 2 is 32. Are we up to 100 yet? Definitely not. So we need to keep going. We need to extend the table. Let's extend it as far as it goes here. 6, 7, 8 years. And we know we're multiplying by 2 each time. It's good to write these in so that we don't forget what we're doing on the side. 32 times 2. Well, we know 2 times 2 is 4, and 2 times 3 is 6, so there's 64. Look at this now. Is 64 more or less than halfway to 100? Because that's the number we're looking for, right? So if 64 is more than halfway, if we double that number, then we just might be almost done. 64 times 2, let's write it out over here. 2 times 4 is 8. 2 times 6 is 12. There we go. 128 dandelions. So in just 7 years, he gets 128 dandelions, over 100. And we don't have to finish the 8th year because it only asks how many years would it take to have more than 100 dandelions. If you want to do that multiplication, you can. It's up to you, but you don't need to because you've reached the answer. So the answer would be 7 years. Here's one last one to look at. This one says I want to make a model. So when we're making a model, that means that we're making a visual representation from this table of values. So in figure 1, we could say term 1, figure 1 is the same thing. We have 5 squares. Now it doesn't tell us what the difference is, how many squares to add or subtract or multiply or divide. So let's see. If our number of squares is 5, 9, 13, 17, we know that they are increasing. So it can't be subtraction and it can't be division. It has to be addition or multiplication. Let's see if the hint tells us anything. So the hint says how many squares are in figure 1? Well, we know figure 1 has 5 squares. That's where we're starting it, right? So if we want to write the rule, we could say start at 5. And what's the difference? What does difference mean? It means we're subtracting, right? So if we want to find the difference between the number of squares in figure 1 and figure 2, we're going to take the bigger number, 9, subtract 5, and we will end up with 4. So looking at this, from 5 to 9, we need to add 4. Now wait a minute, you say, because we subtracted over here. We didn't add. That's right, because we took the bigger number and subtracted the smaller number. So we're going from the smaller number to the bigger number, so that means we have to add. 5 plus 4 is 9. So our rule would be start at 5 and add 4 each time. Okay, let's see if it holds. 9 plus 4 is 13? Yes, it is. So that's what we have to add each time. 13 plus 4 is 17? Yes. Add 4 each time. So here's what we end up with. Figure 1, you can see, has 5 squares. Figure 2 has 9 squares. And if you thought of it differently than I did, if you have the squares slightly in a different pattern or a different orientation, that's fine. As long as there's 9 squares there, and they should be touching, it's just the way that the squares ended up for me. Figure 3 has 13 squares. And again, if you did it differently, that's fine. And figure 4 there has 17 squares. All right, so that's how you can make a model from the table of values that you see here. All right, and that is the end of our lesson. So with that, you should be able to do pages 15 and 16 in your practice book. And if you have any questions, please contact me. I would love to help you out. See you next time.